Let's continue on with number 4. A penny is dropped off the Empire State Building. That's a really tall building in New York City, which is 1,250 feet tall. If the penny's pathway can be modeled by the equation h equals negative 16t squared plus 1,250, how long would it take the penny to strike a 6-foot tall person? So let's envision our drawing. We've got this really, really tall building. I need to draw that better. Really, really tall building. We're going to drop the penny. So we're not throwing it, so it's not going to go up in the air first. We're going to drop the penny. So it's going to fall down. So I want to know, how long will it take to hit a 6-foot tall person? So I'm curious, when will my height be equal to 6? So to solve this, notice my b value is 0, just like we saw in the previous problem, number 3. So when the b value is 0, we can solve using the square roots method. So the square roots method tells me I got to get my x squared, or in this case, t squared, all by itself. So let's subtract 1250 from both sides. So negative 16t squared equals negative 1244. Then I need to divide both sides by negative 16. So I have t squared equals 77.75. Okay, we got that after we typed in negative 1244 divided by negative 16 in our calculator. So if t squared equals 77.75, how I get the t by itself, we square root both sides, being sure to include the positive or the negative. Okay, we type that in our calculator. Type 77.75, find the square root of it, and we're going to get an approximate answer, rounded to the nearest hundredth, of 8.82. I don't want the negative one. I just want the positive one. So at 8.82 seconds, it'll strike a person who is 6 feet tall. Number 5. Some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation for this object's height h at time t seconds after launch is h equals negative 16t squared plus 80t. How long will it take for the fireworks to reach the ground? Where we launch fireworks from is 0, 0. So the fireworks are going to go up and come down. So I want to know, when will the fireworks reach the ground? So when will, sorry about that, I had to hit pause because someone came in the house. I got to remember my train of thought. I want to know, when do the fireworks hit the ground? So when is my height equal to 0? I can factor this. My greatest common factor is negative 16t. And then my other factor is t minus 5. Then I solve my two pieces. Okay, what makes negative 16t equal to 0? Well, that's going to be 0, which would make sense because at time 0, my fireworks are on the ground. And then what makes t minus 5 equal to 0? Well, that would be 5. So after 5 seconds, they've reached the ground. Please hit pause and work through question 6. Question 6 is super similar to the front side, the B part of 1, 2, and 3. How many of you actually drew a picture to help model the situation? Good job if you did that. The roller coaster will start at 0, 0. The equation of the ride looks like, or the graph of the ride would look like this. What is the maximum height? So the maximum height is my vertex. To find the vertex, I first have to find the x value of my vertex. So my negative b over 2a, rounding that to the nearest hundredth, I get 3.16. And then to find the height, to find my y value of the vertex, I have to plug 3.16 in for t on my equation. So I plug that in, type it in on my calculator, and we get 169.39 feet. That is quite a ways up there for a roller coaster. Number 7, Eva is jumping on a trampoline. Her height, h, at time t can be modeled by the equation h equals negative 16t squared plus 20t plus 6. Would Eva ever reach a height of 14 feet? Well, let's think about it. If Eva is jumping on the trampoline, she starts at 0, 0, jumps, and comes down. So I want to know, will Eva ever get above 14 feet? How do you think we'll go about finding whether Eva will reach a height of 14 feet? Well, let's figure out what her maximum height would be and see if it's more than 14. Okay, will she surpass 14 in her jump? So let's find the max height just like we did in question 6. So hit pause to find that. In finding my vertex, the x-coordinate of my vertex would be 0.625. Because that terminated, I used all 3 decimal places. When I plug 0.625 in for t on my equation, as I use my calculator and type that in, I get 12.25 feet. So the maximum height Eva will jump is 12.25 feet. So she will never get to 14 feet. So my answer is no. And my reasoning being, her max height is 12.25 feet. Our last problem. An astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the baseball 2 meters above the ground. So let's think about what that looks like. So letting go at 2 meters above the ground. So it's going to start at 2 meters above the ground. And the astronaut throws the baseball upwards. So then the path of it goes up and comes down. The equation of the baseball pathway can be modeled by that equation. The same experiment is done on Earth, in which the pathway is modeled by the equation of that. Okay, so my graph is going to look this similar shape, but we know that the moon has very little, if no gravity, and so it's going to take a longer time to stay in the air on the moon than it will on Earth. So the question says, how much longer will the ball stay in the air on the moon compared to that of the Earth? So I need to know in both situations, when will my ball reach the ground? So we've got the moon. Okay, when does my equation equal 0? And then we've also got Earth. When does my equation equal 0? in order to solve these, we are going to use the quadratic formula. So we've got two separate parts here. So I'm going to work through the moon with you on the quadratic formula, and then I'm going to have you work through the earth part. Remember our quadratic formula. Sing the song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So my a value for the moon equation is negative 0.8. My b value is a positive 10, and my c value is a positive 2. So x equals negative b plus or minus the square root of b squared, 10 squared is 100, minus 4ac all over 2a. Okay, so x equals negative 10 plus or minus the square root of something over negative 1.6. So we pull out our calculator and we type in our calculator 100 minus 4 times negative 0.8 times 2. Okay, when we do that, we get the square root of 106. Okay, now to type this in our calculator, typically when we did solving by square root, we stopped right there. Okay, but I actually want a decimal answer here. Okay, so to type that in, we type in negative 10 plus the square root of 106, hit equals, then hit divide by negative 1.6. When we do that, we get approximately negative 0.2. Okay, now let's do our other answer. Negative 10 minus the square root of 106, hit equals, then divide by negative 1.6. And you should get 12.7. So I'm not interested in the negative answer. I just want that. Okay, so what I want you to do now is the same thing for Earth. Figure out your A, B, and C values, plug them in your quadratic formula, and then get your decimal answers. All right, on Earth, hopefully you found that the time it's going to take for the ball to reach the ground is 2.22 seconds. So the question was, how much longer will the ball stay in the air on the moon compared to on the Earth? So what I have to do is subtract my answers. And I find that due to gravity, the ball is going to stay in the air 10.48 seconds longer on the moon than it will be on Earth. Congratulations, you've made it to the end.